Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is matrices. In this video, we will be focusing on NCERT solutions for exercise number 2. In the first problem, we are given matrices A, B and C. We need to find A plus B. We know that matrices must be of the same order when we add them, and we add element by element for each row. So this will be 2 plus 1, the first element in the addition. Second will be 4 and 3. Similarly 3 minus 2 and 2 and 5 will be added. This will give A plus B as this matrix. In this problem, we need to subtract A minus B. Again, subtraction will be done element by element for each row and column. So this will be 2 minus 1. This will be 2 minus 1. Similarly, 4 minus 3. 3 minus minus 2, because there is already one minus here, and here also minus is there. Then 2 minus 5. On simplification, we will get this matrix as the answer. In this problem, we need to find 3A minus C. So 3A can be computed like this: 3 into A. This is matrix A. And whenever we see a scalar outside, it has to multiply each element of the matrix. So 3 will be multiplied by 3 will be multiplying 2. 3 will multiply 4, 3 will multiply 3, and 3 will multiply 2, and this will be 3A. Now 3A minus C, standard subtraction of matrices we know, and we will get the answer like this. In this problem, we need to find the product AB. Now the important thing is matrices should be compatible. What is compatible? We know that this matrix is 2 by 2 and this matrix is 2 by 2. This is A and this is B. So this number of columns of first matrix must be equal to number of rows of the second matrix, which is true. So the matrix are compatible, and the final result will be a 2 by 2 matrix. Will be a 2 by 2 matrix. So we know how to do multiplication. We take the first row and multiply with the first column, each element by element, and then add it. For example, this will be 2 into 1, 2 into 1, 2 into 1, then 4 into minus 2, 4 into minus 2. Similarly, this element can be computed by multiplying the first row with the second column. Similarly, these elements can be computed by multiplying the second row and the first column, and so on. We keep doing it. This is simple mathematics, and we get the solution as this matrix. This is product AB. Now we want to find BA. Instead of AB, we want to find BA. We very well know that AB is not equal to BA. Please note that. Matrix multiplication is not commutative. So again we see a 2 by 2 matrix. This is also a 2 by 2 matrix. So it is a compatible, because this term is equal to this term. So this will result in a 2 by 2 matrix. 2 by 2 matrix. So again we know first row will be multiplied with the first column, element by element, and added. So this will result in this value. Similarly, first row will be multiplying the second column, element by element. So like that we will proceed. We have seen it earlier, and we get the solution as this. This is the final answer. Now compute the following. This is a simple addition. So we do addition element by element. So A will be added with A, B will be added with B, like this. Minus B will be added with B, and A will be added with A. So these are the addition done, and we get the solution as this. Again we need to add these two matrices. They are of the same order, so we add element by element. So a square b square we'll add with 2ab. That's what we are doing here. A square plus b square plus 2ab. Similarly, b square plus c square will be added with 2bc. That's what we are doing here. Similarly, for other elements of the matrices. We also know that a plus b the whole square is a square plus b square plus 2ab, and a minus b the whole square is equal to a square plus b square minus 2ab. This is trivial mathematics. We know from our 9th and 10th standard. So these expressions can be simplified as these expressions. This is the final answer. Again, this is matrix addition, so we'll add term by term or element by element, cos square plus sin square x, then sin square x plus cos square x, and so on. We know that sin square x plus cos square is 1, so we can replace sin square x plus cos square x as 1 for each of the terms. This is our solution. So this is matrix multiplication. So this is a 2 by 2 matrix. It's given here. This is also 2 by 2 matrix. So this term must be equal to this term for compatibility. Then only we can multiply. Yes, they are equal. So we can proceed with the multiplication. And the final result will be 2 by 2 matrix. This term 2 by 2 matrix. For example, if m into n matrix is multiplied with n into p matrix, this term must be equal to, and the result will be m into p matrix, these two terms. Please remember this. So this is simple multiplication. The first row will be multiplied with the first column element by element, a into a plus b into b. Similarly, first row will be multiplied with the second column, a into minus b and b into a. Similarly, second row will be multiplied with the first column and second row will be multiplied with the second column. We get the final answer as this on simplification. Compute the product. So this is having 3 rows and 1 column, and this matrix is having 1 row and 3 column. So these terms are equal, so it is compatible, and the final result will be a 3 by 3 matrix. So we just do that again. 1 will be multiplied with 2, 1 will be multiplied with 3, and 1 will be multiplied with 4. 2 will be multiplied with 2, 3 and 4, like that. Similarly, 3 will be multiplied with 2, 3 and 4, and we will get the matrix as this. So we know that whenever you see a scalar quantity like this outside, we need to multiply each of these terms with this scalar quantity. So that's what we are doing now. So cos theta will be multiplied with each of the terms, cos theta into cos theta, cos theta into sin theta, cos theta into minus sin theta. And similarly here, each of the term here in this matrix will be multiplied by sin theta. That's what we are doing here. On simplification, we get cos square theta sin theta in these terms. But we know that and adding on that, we get cos square theta plus sin square theta as 1. The other two terms will vanish and we get those as 0. So we get a solution as an identity matrix. This is nothing but an identity matrix. We are given x plus y as this and x minus y equal to this matrix. We need to compute x and y. We remember in our linear equation that when x plus y is some quantity, say 3, and x minus y is some quantity, say 2, we can add these two terms and get 2x equal to 5. But here we don't have a single number 3 and 2. We have a matrix here. but we can proceed in a similar fashion. We'll add these two terms, x plus y and x minus y. So that's what we are doing here, x plus y and x minus y. Why we are adding? We want to get rid of y here. And we will add the matrix here instead of the numbers. So we are adding the matrix here. So we will get 2x, y will get cancelled, 2x will be 10, 0, 2, 8. But we need x. So x will be equal to half of 10, 0, 2, 8, which will be, now since it is half, each of these numbers will be divided or multiplied by half. So 10 divided by 2, 5, 0, 1 and 4. So this will be x. Once we can substitute the value and get y. In this problem we need to find x and y if this term linear equation is equal to this. Now we see that this is 2x plus 3y equal to some quantity, say a, and 3x plus 2y equal to some quantity b. They are matrices, but just for the sake of simplification we have written like this. Now how to solve this linear equation you very well know. We'll multiply this by, say, term 3. So this will become 6x plus 6y equal to, all throughout we are multiplying by 3a, and this term will multiply by 2. So 6x plus 4y equal to 2b. Why we are multiplied by 3 and 2? So that these terms become equal. Then we can subtract them and get the solution. But here instead of a and b, we have the matrices which can be solved similarly. So we multiply the first equation by 3 and we get here 3 into 2x plus 3y equal to this, and we get 6x plus 9y as this matrix. Similarly, the second equation we multiply by 2 and get the solution as this. Now we subtract 2 from 1 so that we can get rid of x. That's what we are doing here. We are subtracting 1 from 2 and getting rid of x here. So 9y minus 4y will be 5y, and on the right side it will get simplified to this matrix. So y will be 1 over 5 into this matrix. This is our solution. Now we found y. We can substitute back in this equation to get our x term. So we got x as this. So this is the final solution where x is this and y is this. This is our final answer. If this condition is given, we need to find x and y. We very well know that if a scalar is sitting outside a matrix, we have to multiply each term by that scalar. So this will be 2x 3x, this will be 2x 3x, this will be minus yy, and this will be 10 phi as it is. So we can add these two, 2x minus y equal to 3x plus y, this will be 10 phi. So we can easily solve this. We can, like a linear equation, 2x minus y equal to 10, 3x plus y equal to 5, this will get cancelled, 5x equal to 15, so x equal to 3. We can substitute x equal to 3 into this, so 9 plus y equal to 5, and y will be minus 4. So this is our solution. X will be 3, y equal to minus 4. This is the final answer. We are given f of x as a function this. We need to show that f of x into f of y is equal to f of x plus y. When f of x is this is f of x. So f of y will be this function. We just replace x by y in this. Now we are multiplying these two. This is our LHS. F of x into f of y, we are trying to find it out. We are multiplying these two. We multiply these two and get this expression. We very well know this is cos x plus y. This is sin x plus y. So we simplify this. We know that cos A cos B minus sin A sin B is cos x plus y. Similarly, sin x cos y plus cos x sin y is sin x plus y. Merely replace that terms here and get the answer like this. This is f of x into f of y. But I'm sorry, f of y. But what is this? This is nothing but f of x plus y. So we solved LHS as f of x, f of y. We get it as f of x plus y. So we have proved. We need to find a square minus 5a plus 6i if a is given this. So first we find a square. A square is a into a matrix, simple a into a matrix. We get it like this. Now this is a square, this is 5a, this is 6i. 6 into I identity matrix is diagonal. All elements are 1 and other elements are 0. So this is a scalar outside, so we multiply each element by 5 in this matrix. Similarly, 6 will be multiplying each element in this matrix. On simplification, we get a square minus 5a plus 6i as this matrix. This is the answer. If a and I are given, we need to find a square equal to ka minus 2i. So again, a square is a into a, so we can multiply these two matrices in a standard way and get solution as this. Now we compute this term, a square k minus 2i. This is a square ka. This is a matrix, this is I matrix. So on simplification, now k is sitting outside the matrix, so each term will be multiplied by k. So this will be 3k minus 2k, 4k minus 2k. Similarly, 2 will be multiplying each of these terms. 2 into 1, 2 into 0, 2 into 0 and 1 into 2. So on simplification, we get this equation. Now we need to find k. So we can write 3k minus 2 equal to 1 from this. 3k minus 2 will be equal to 1. So 3k equal to 3, k equal to 1. This is the answer. A trust has 30,000 that must be invested in two different types of bond. The first bond pays 5% interest and the second pays 7%. Using matrix multiplication, how to divide this 30,000 rupees among two types of bond such that annual interest is first 1800, second part is 2000. So we invest on first bond say rupees x. Since we have only 30,000, the second investment on bond will be 30,000 minus x. So we can write a matrix as x by 30,000 minus x. This is first bond and second bond. So interest is given as 5% for the first bond. We write it as 5 by 100. This is 7 by 100. Now we multiply B into A matrix. That is interest per bond into investment will give the total annual interest. We multiply 5 by 100, 7 by 100 into x. 30,000 minus x. We get this as the total annual interest. This is given as 1800 in the first part. 1800. So we can easily solve this as x equal to 15,000. So this must be invested in the first bond and the balance 30,000 minus 15,000 equal to 15,000 must be invested in second bond. In the second problem, we have total interest of 2000. So we put it as 2000. Again on simplification, this equation, we can get x equal to 5000. So this must be 5000 must be invested in first bond, and the balance 25,000 in second bond. We are given certain matrices whose orders are given here. We need to find what is the order of this matrix Py plus Wi. We want to find this. Then what condition will be satisfied? It is given that the order of P is P into K, order of P is P into K, order of Y is 3 into K. So when we multiply Py, P into K, 3 into K, we will get this matrix size Py as P into K, this P into K. Okay, and another condition is that K must be equal to 3 for matrix multiplication compatibility. So we got K equal to 3 and matrix Py will be order P into K. Now we see the next condition Wi. W order is n by 3, order of Y is 3 into K. So 3 is satisfying. So this matrix will be of the order n into K. That's what we have written, n into K. Now since these two matrices are to be added up, K is equal, this is 3. K is 3. So P into, this is P into 3, this is n into 3. Now for this matrix to be added up, P must be equal to n and K must be equal to 3. So option A is correct. Again we are given certain matrices, and if n equal to P, we want to find the order of this matrix 7x minus 5z. Order of x is 2 into n, it is given here. So when we multiply 7x, order will remain same because it is being multiplied by a scalar. Again order of matrix Z is 2 into P. So 5z will be remaining same because it is multiplied by a scalar. Since n equal to P is given, so instead of 2 into P order, it will be 2 into n can be told. So the order of 7x minus 5z will be 2 into n matrix. So option B is correct. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.